If you live in Waterloo Region, most of your drinking water is groundwater. You can find groundwater in an aquifer, an area underground where the spaces between the sand grains, rocks, or gravel are filled with usable amounts of water. During this presentation, we will use this working model of a groundwater aquifer to learn more. To start, I'd like to point out the different parts of the model. The top of the model represents the ground or surface where we live. This is where you will also find surface water, in this case a lake and a stream. Underground are the layers of different materials filled with water. This represents groundwater in an aquifer. Water moves between the surface water and the groundwater. Groundwater can seep up into surface water, and surface water can soak into the ground to become groundwater. The model's pump represents the precipitation or rainfall. Just like the changing weather, we can switch the pump speed to increase or reduce the amount of water. Sometimes it rains a lot, other times it only rains a little or not at all. After the water passes through the pump, it soaks into the ground to become groundwater in the aquifer. Water is added back into the aquifer through recharge or infiltration. This can happen through precipitation, such as rainfall or when the snow melts, or from water seeping into the aquifer from surface water in a lake or stream. Underground, there are different layers of materials that make up the aquifer. Each layer has many tiny spaces where you can find groundwater. The layers in one aquifer can be very different from another. Aquifers in much of Waterloo Region consist of sand and gravel with layers of clay. The exception is most of Cambridge, where the aquifers are in bedrock. This model represents a sand and gravel aquifer with its layers of sand, clay, and gravel. Pipes or wells are put into the ground to collect the groundwater we use for drinking, cooking, washing, and so much more. The clear tubes represent these pipes or wells. Wells can be different depths depending on how far down you need to go to reach the groundwater. The region of Waterloo has about 120 supply wells that can be anywhere from 30 to 90 meters deep. There are also a few terms or words you might hear when describing a groundwater aquifer. Water table, the area under the ground where you can first find water when a hole is dug. Unsaturated zone, the area above the water table where the sand, rock, or gravel isn't filled with water. Saturated zone, the area below the water table where the spaces in the sand, rock, or gravel are filled with water. Aquitard, compact layers of clay that act as a barrier for groundwater. Unconfined aquifer, an aquifer that receives its water from the surface where we live. And finally, confined aquifer, an aquifer contained between one or two aquitards and receives its water from an unconfined aquifer. Here's these terms again, but where you can find them on the model. Water table, unsaturated zone, saturated zone, aquitard, unconfined aquifer, and confined aquifer. Now that you're acquainted with the model and the parts of an aquifer, let's watch it in action. Groundwater doesn't like to stay in one place for too long. By adding food coloring to the model, you can see the movement of groundwater. While underground, the groundwater slowly moves a few meters per year through the spaces between the sand, rock, or gravel. As we zoom out, the food coloring shows us the path groundwater takes as it moves underground. Eventually, the groundwater will make its way into the lake or is pumped out of the ground with the help of a well. The continual movement of groundwater and how much water soaks into the ground through recharge can affect the water table. By changing the speed of the pump, we can see what happens to the water table when we add more or less water to the aquifer. Slowing down the pump means less water going back into the ground. This results in the water table going down. Speeding up the pump increases the amount of water soaking into the ground, causing the water table to go back up. Let's now take a look at the surface water in the lake. Slowing down the pump represents less rain soaking into the ground. The continuous movement of the groundwater and less water being added back in the ground can change the location of the water table. What happens to the water levels in the lake when the precipitation decreases and less water is soaking into the ground? If you look closely at the wells, you might also be able to see the water levels dropping. Now let's increase the speed of the pump to represent more rain soaking into the ground. How does more recharge or water soaking into the ground affect the water table? Do you see the water levels in the surface water slowly going back up? How about in the wells? Think of the water table like a cup or glass of water. When you add more water to the cup, the water levels or water table goes up. When you take a drink from the cup, the water levels or water table goes down. But what if you take a drink and you are adding more water back to the cup at the same time? The water levels or water table will not move as much. We can also pump water out of a well. To do this, we insert a tube attached to a syringe. This represents the action of pumping groundwater out of the well. Look closely at the well. Can you see the groundwater level going down? Once the pumping stops, the groundwater in the well goes back up. Sustainable use of groundwater ensures we have drinking water for now and in the future. Collecting information on groundwater is an important part of the Region of Waterloo's Groundwater Protection Program. This includes measuring groundwater levels in the aquifers, tracking the amount of groundwater pumped from each supply well, and recording the amount of precipitation from rainfall and snowmelt. Making sure we always have enough groundwater is also an important role you can play. Think about how you use water and what you can do to use less. This could be something as simple as taking a shorter shower or turning off the tap while you brush your teeth. To learn more about your drinking water distribution system, visit the Region of Waterloo website at www.regionofwaterloo.ca/learnwater.